Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing nodes at odd levels of a binary tree. First, let us take an example. We traverse nodes level by level. We switch odd level flag variable after every level. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. Note that we will be using a queue data structure. We pass the root node, which is 3, to print odd nodes function. So, root will point to 3. Since root is not null, we push the root node into the queue and take a boolean variable isOdd, which we set to true. We enter the outer while loop and take a node count variable which stores the number of elements in the queue. So, node count will be 1 as there is only one element in the queue. As node count is greater than 0, we enter the inner while loop and take a node which point to queue's front. So, node will point to 3. We check if isOdd is true. As it is true, we print data of node. So, 3 is printed. Next, we pop 3 from the queue. Now, we left and right children of node 3. So, 2 and 5 will be enqueued. Then, we decrement node count. As node count is not greater than 0, we break out of the while loop and set isOdd to not isOdd. So, isOdd will be false. We continue with the outer while loop and now node count will be equal to 2 as there are 2 elements in the queue. Since node count is greater than 0, we enter the inner while loop and now node will point to 2. As isOdd is false, we don't print node's data and in the next step we dequeue 2 from the queue. Now we enqueue the left and right children of 2. So 1 and 4 will be enqueued. Then we decrement node count. As node count is greater than 0, we continue with the inner while loop and now node will point to 5. Since isOdd is false, 5 is not printed and we pop 5 from the queue. As node 5 does not have any left or right children, nothing is enqueued and we decrement node count. Now as node count is 0, we break out of the inner while loop and set isOdd to true. We continue with the outer while loop and now node count will be equal to 2 as there are 2 elements in the queue. Since node count is greater than 0, we enter the inner while loop and now node will point to 1. Since isOdd variable is true, we print 1. Hence, 1 is printed. Next, we pop 1 from the queue. Since the left and right of 1 is null, nothing is enqueued and we decrement node count. As node count is greater than 0, we continue with the inner while loop. Node will point to 4 and 4 will be printed as isOdd is true. Next, we pop 4 from the queue. Since the left and right of 4 is null, nothing is enqueued and we decrement node count. As node count is not greater than 0, we break out of the inner while loop and set isOdd to false. Now node count will be 0 as there are no elements in the queue. Since node count is 0, we break out of the outer while loop as well. We have the final output. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.